Okay, so in this video I'm going to create a rig for the shot camera. This will help me to adjust the scale of the projection and also be able to distinguish the shot camera from other cameras projecting onto the surface, which is really important for comparison purposes. So the first thing I'm going to do, I've got some nodes already set up here. The first thing I'm going to do is create a simple rig setup for projection. So I'm going to take my scanline renderer and connect it up to my geometry. I'm just using a constant node here to actually define the aspect ratio at shot camera level, which is, you can see it, it's set to the root format, and this is based on the fact that I'm going to be outputting from my scanline renderer at the end of the day a shot that's at 1920 by 1080 resolution. So I'll look at my viewer to the scanline renderer so that we'll be able to see this in 2D shortly. So that's the first part of the projection rig setup, and then the second thing I'm going to do now is I'm going to set up a projection. So I'm going to want a project 3D shader. I'm going to want to connect to my shot camera, and these are just this bit of projection. If I just go into 3D view here, we can see this is just an FBX of one of the buildings from my project. And then if we look at the shot camera, we can see that the shot camera is down there, and the shot camera has the movement applied to it, as we've seen so far. Okay, so the final thing that I'm going to do is I'm going to project this texture onto the surface. Now obviously we're projecting through a shader which needs a projection camera, so for that I'm just going to make a copy of my shot camera. I'll just make sure I'm on the first frame. So currently I seem to be on frame 12. Off. Alright, so there we are, we're on the first frame. So I'm going to copy the camera at the first frame, so we know we're actually projecting from the first frame in the sequence. I'm just going to double click that and call that projection cam, proj cam, as I tend to call these cameras, and I'm just going to put frame 1 so that I know what frame it's being captured from, and I'm just going to colour it. So again, visually we can distinguish in the node graph one camera from another, and I'm pretty big on this. I think that it's important to create as many visual clues as you possibly can as you go through this process. So what we can see now in this scene is we can see this checkerboard, which I'll just remove that expression that I used earlier on when I was just practicing. So I think it's important that you have as many visual things in your node graph as you possibly can to help you along the way. So we can see that texture there being projected from the camera onto the geometry. Okay. Now at the moment this projection camera is actually animated, so it's not being projected from frame 1 unless you're on frame 1. It's actually moving all the way through, but actually I quite like to leave it like this, so I'm actually going to rename the projection camera, and I'm just going to take that frame off, because that's normally when we're locking off and removing the animation from a shot camera. Okay, I'm sure I'll be coming to that shortly. So this is a good way of actually being able to see what is being rendered or what's being projected onto the geometry at any given time from the position of the shot camera. I'm just going to set my properties to 2, so I can only have 2 node properties accessible at any given time, and I'm just going to click on my checkerboard so we can have a look at it, just so we can see how this has been set up. We can see that it's been set up at the native 1920 by 1080 resolution. As soon as we create a checkerboard, it will default to that if that's what the settings of the NewScripts project are. What I have changed is by default the checkerboard will come in at a size of 64 pixels. I've actually set that to 100 pixels, and the very specific reason why I've done that, which we'll come on to, but essentially it's down to the fact of uniformity of numbers, so that we can actually manage the resolution. We can get a visual indication of what the resolution is from the squares on the checkerboard, which we can now see here. If we go into any of our squares, and I just put my cursor there on the edge there, you can see the value down here, look. You can see the value there at 960-ish. So if I come across to this side, we can see that finishes around 1060. So we know that the XY value of each of these squares is exactly 100 pixels, and that's great for knowing sort of the amount of resolution and being able to compare and contrast. If we take our scanline renderer back to the, or should I say, take the viewer back to the scanline renderer, and we take a look through this, we can see that as the camera comes around this building, just actually click on this so we can actually see the geometry as well. I'm sure I can do that from this view, so I'll do it inside the OpenGL view instead. So we can see that as we come round to this building, we can see this. We can see the size of these boxes, and we can see that those boxes actually represent a resolution, which in this case is 1920 by 1080, and that's depicted by the size of the squares essentially. Let's take a look at what would happen if we increase the resolution. So I'm just going to make a copy of this checkerboard. What I'm going to do inside here is I'm going to come into it and I'm going to make a new format. So, and I'll just call it double res, and I'll just multiply each of these values by 2, and you can see what that gives me. In fact, what I'll do here is I'll set that to 4000 by 2250, which I know gives me the same aspect ratio. You can see there it's giving me an aspect of 16.9. That's just a little bit over double, but you know, call me anal, but I like round figures. Okay, so I'm going to call that double res, and we can see that's now projected into here. So if we just take a look, I've just come back into 2D, and I'll just put my viewer so that we can just toddle between the sort of number 1 and number 2, and we can see now with our square that that is our native resolution and that's our double resolution. So what we should be expecting therefore is that as we increase the resolution of our rig here, what we should expect to see is we should expect to see these checkers reduce in size. If we come into them, I'm looking at the double res at the moment. You can see there that as I put my cursor there, you can see that's 2300-ish, and if we come over here, we can see that's 2400. So we can see that the values are still 100 pixels on this double res one. There's still 100 pixels from one side of the square to the other square, so the pixels are still the same as they are here. You can see there 1060, 1160. But of course the difference, they look completely different. Effectively, the only way to make them look the same will be to change the size of the squares on the native resolution down. Now if we toddle again between the two, we can see now that they look pretty much the same, even though one's double resolution and one's not. Don't be fooled by this. It's still the ordinary native resolution. Just to make it the same, I've had to reduce the size of the squares to accommodate. Which is obviously not what we want to do, because that's obviously just a way of masking the fact that we're still at native resolution here, we're at a higher resolution here, but you can see how they look the same when you change the size of the squares. Okay, the point of this really is that as we start to go through a projection, we're likely to have our shot camera projecting, but we're also liable to have several other shaders, each projecting from a static point along the camera path. So for example, on this particular shot, if I just jump back into the 3D view so that we can actually sort of plot this shot on a little bit, and I'm just going to come back into this OpenGL view, and we'll just come in here. The shot starts over here where we're looking at this side facade, but it ends over here where we can also see this front facade as well as the side. Now obviously the front facade isn't visible from there, so there would be no matte painting projecting onto that side. So we would have to have a second projection at this side giving us this information. So we would have at least 2 cameras projecting the information onto this particular shot. and I suspect we would probably have 3, because you can see, for example, up here that if we look at the top of the building here, we can see that it quickly starts to come down, and we quickly start to see areas where there is no coverage of the matte painting onto the geometry. So we would probably have to patch somewhere in the middle to patch this top area, which is obviously not being seen, and therefore not providing any coverage, because the matte painting originally is here. This would be where we'd done the matte painting, and we can see that entire section of the top part of the building there. That would be uncovered when we actually came down here, and so we would have to be patching, get some of that back at the end, but only to there. So all that section there has got to be filled in somewhere. So we'd probably be somewhere in this area, projecting into that particular part. So there's probably going to be 3 projection cameras just projecting the matte painting onto this surface over the course of these 125 frames. So this allows us to be able to distinguish between each of the projections, and it also allows us to compare and contrast, so that we make sure that we maintain our resolution. So, for example, that we don't suddenly get some of our boxes getting very big, which means that they're running out of resolution. So it gives us a way of actually knowing where and when we need to increase the resolution of our particular projections. Okay, so I'll just shift that out of the way. So what I'm going to do is I'm just going to make this a little bit easier for us to be able to see it as a projection element. So what I'm going to do is I'm going to add a text node. This is a great way of being able to distinguish the shot camera from other projection cameras. So inside this I'm just going to type my name for my camera, which in this case is shot cam. You can see it appearing up there in the top left. What am I going to do? I'll center that. I'll make it Arial. It's gone off screen, I appreciate. Bold, and I'll increase the size, double the size. Bring it down into the center here. Okay, I'll maybe move it up. The reason why I'm moving it up is because I'm going to add a little bit of text down here a little later on, and I just want to be able to see that. And in the colour, I'll just make it red, so it's really gaudy, but it does distinguish from the green background. Okay, so I've made that text box there. And obviously what that means now is that when we're projecting, so if I go back to 3D, this will look pretty grotesque, I would have thought, when we're in 3D. Again, just looking at this through the projection camera, we can see that it's not great there. It's not moving around. But if we were to lock off this camera at a particular frame, then we would actually see that fixed rather than sliding around. And it gives us a visual reference of what the shot camera is in relation to the scene, and as opposed to any projection cameras that we've got, so we can distinguish. So what I want to do now is I want to set this up so that I can actually change the resolution of the checkerboard on my shot camera, but without having to keep coming into my checkerboard here and making changes to this. I don't want to be doing that. That's cumbersome, it's time consuming, and it's potentially introducing the possibility of human error. So I want to try and eliminate that as much as possible. And I'm going to do that just by adding an expression which is going to allow me to control the size of the squares from a single controller. And for that I'm going to use a reformat node. So I'll just add in a reformat node, and this is going to live in this particular stream here. So this is going to be affecting the checkerboard, and the text box is just going along for the ride. This just needs to be in this particular place. It won't actually affect the text because it's going to be speaking to the checkerboard directly via an expression, but nevertheless it needs to be in that stream, because obviously when we change the resolution it'll also increase the size of the text because it's above it in the path. Okay, so the first thing that I want to do inside the reformat is I want to change to scale, and you can see this just gives me this simple slider now with a value scale, and we can use that to scale up and down the checkerboard. So we can see now that I'm actually going to come back with my viewer back to this reformat, so we're actually working in 2D for now. It's more helpful than trying to work it out when it's being projected onto a surface. Okay, so what we can see at the moment on our checkerboard is we can see that at a scale of 1 we can see that our squares, you can see there 860-ish across to 960-ish, so we know that they are 100. Now, map painters typically create their work at twice the size of the resolution of the display format resolution, which we know that we're going to be displaying this as a final piece of work at 1920 by 1080. So a map painter would typically create a map painting at twice that format. So for the sake of this, I'm just going to actually increase the scale to 2. Okay, nothing apparently happened. Let's look at our format. We can see there on that particular one there 1717-ish, and across here 1917-ish. Okay, so now even though the change they didn't actually anything appear to change within the visual appearance of this, these squares are no longer 100 pixels. These are actually 200 pixels, and that's going to make comparing and contrasting with any other projection checkerboards that we've got in our scene very difficult. We want them always, all the time, to be 100 pixels. Okay, and we now know that they are 200 pixels. I mean, at the end of the day, I guess it's logical that if you're doubling the resolution, it's also going to double the size of the squares, but that's not really helpful for us in this particular case. We need to find a way of fixing that. Okay, and the way that we fix that is by adding an expression into the size attribute. So to do that, I'm going to come into here and I'm going to add an expression. And within the expression field, I'm just going to type reformat. If we look down here, our reformat node is reformat 1. So reformat 1 dot scale, and we can see that's giving us a result of 2, and it's giving us a result of 2 because down here in the reformat we've set that to 2. Okay, so I'm just going to accept that. Now this is something pretty funky's happened down here. What it's actually done is it's actually set the size of each square to 2. So it's made the squares absolutely huge relative to the screen, and that would give us absolutely no information. So to fix this, we need to come back to our expression. In this case, we're editing the expression because it's already got one in there. And what we want to do is we want to put a multiplier on that. So I'm just using a multiply operator, and I'm just going to multiply that by 100. And we can see straight away that this is probably not giving us what we want either. This is giving us a result of 100. But I'm going to accept it for now. So what we can see now is we can see now that it's set the size of our squares to 200. So if I come into here, for example, we can see the value of 15, 19 across here to 1990. So it's actually increased them by 400. So it's obviously multiplying and then multiplying over somewhere against this scale value. Yes, of course, because obviously the checkerboard is now set to pixel size of 200, and then we're getting the scale effect down here, which is multiplying it by 2 a further 2, so we're getting it increased to 400. Okay, again, it's not what we want. What should be happening is as we increase the scale, so as we start to increase this scale, we can see that as I'm scaling up and down on the reformat, we can see that is having an effect on the size of the squares inside the checker box. But we can see that as I increase the size of the scale, it's actually making the boxes bigger. Whereas what I want is that as I increase the scale, I want them to get commensurately smaller. So how do I do that? I've obviously got to go back to this expression, and what I do inside this expression is I just put a divider at the front. So I just put 1 divided by, and we can see that this is now giving me a value of 50. So if I click now, what we should see now is that as I increase the size of the, or should I say, as I increase the resolution, the size of the squares gets smaller. But hopefully what we can see is if I set that to a scale of 2, and we come in, so there, 2020, 2120. So now we've got back to our value of 100 pixels. even though it's saying, in the square, even though it's saying 50 there, what it's doing is it's saying 50 there, and then it's adding the scale factor. So how this is effectively working, if I just come back to my edit expression, and we can see the value, the result of 50 there. If I just chop off that multiplier operator from the front there, and we can see the result 1.5, 0.5. So what's actually happening now is that 1 being divided by the scale is giving us a value of 0.5, and then the operator going on is multiplying the 0.5 by 100. So 0.5 multiplied by 100 is 50. So if I change the scale factor say to 4, we can see now the scale that's changed to 25. So again, it's the same principle. So if we again go back into the expression, we've got, again I just get rid of that, then the scale factor being divided by 1, so the scale at the moment is 4 being divided by 1 is giving us a value of 0.25, and then 0.25 multiplied by 100 gives us a value of 25, and 25 multiplied by the scale value of 4 is bringing us back to 100, as with when we were at 2. Then the scale value of 50 multiplied by the scale value of 2, which is kicking in just here, is giving us the value back of 100. So wherever we are inside this scale value, even when we're down in these obscure values down here, we won't go that low because we'll still get a value of 100. So you can see there that value is approximately 670 odd, and we'll come over to this end and it's 770 odd. So that value is always going to be 100 irrespective of the scale. I'll set that back to 2. And there we go. We can now control the resolution of the checkerboard that's being projected on from the shot camera, and we can do it just simply by controlling it from this scale slider. Wherever we take that, the squares that are shown visually inside the checkerboard will always be 100, so we will be able to compare that with similar checkerboards that are also in the scene being projected from static projection cameras. And that's the key to it really. It's just making sure that we can basically do like-for-like comparisons in the 3D environment against different projections. Okay, so I'm going to finish up. I mentioned earlier on that I've moved this text box up here, and I just want to show how we can actually append this text so that it actually gives us some feedback based on this resolution. So at the moment the resolution is giving us a scale value of 2. So what I'm going to do is I'm just going to open up my text box, and we can see we've got my message here, and I'm just going to append this. So I'm just going to drop down with a carriage return, and I'm going to type scale multiplied by, and this is where I put the little bit of code in. So I'm just going to open with a square bracket, and I'm going to type value space and then my node reformat 1 dot scale, and then close the square bracket. We can see that that's automatically added this little value into this text box, which I know is now only just going to occupy two lines there, so I can recenter it, and that value there is always going to change. So again, if I just come back to my reformat node and I just start to make changes to my reformat node, you can see there that wherever I put this, you can see that as I increase the scale, you can see the checkboxes are reducing in size, which is what we want, but the pixels are always 100. So even when they're small like that, it just means we've got 100 pixels occupying a smaller area, therefore high resolution. But you can see that wherever I go now, the text automatically adjusts, so I can constantly see where I am in relation to the global scale factor. Okay, so that is the first part of setting up the camera rig, which is basically to set up the rig for the shot camera. I'm going to come back to this with a tutorial later on and actually show how to set up a similar rig, albeit slightly more complex, for a projection camera.